Hello, I'm Frank Linton, and I'd like to talk to you about a particular colony monitoring technology that I've been working on recently. This is a temperature sensor grid and the things you can do with it. Let's start with a thought experiment. Suppose you could put thousands of temperature sensors inside a beehive. What might you be able to infer about the colony's activities? While it seems reasonable that you could guess something about the winter cluster, it would seem reasonable you could know something about the start and end of the brood rearing period, and also that you might be able to know something about the quantity of brood, and perhaps some other things as well. Well, I didn't have thousands of sensors, didn't have the opportunity to put thousands of sensors into a beehive, but I did get the opportunity to put dozens of sensors into a beehive, about 3 dozen, in fact. And I put them in 4 rows of 9 into an 8-frame colony. Put them into this modified inner cover, which has slots in it for the bees to pass through, so this can go over any box. And the temperature sensors are between the frames or between the last frame and the wall of the hive. And this grid was built for me along with all the software on the circuit board you see in the picture below by some graduate students at the Catholic University of America. Item 3 on this grid is the exterior temperature sensor, and it records the temperature outside the hive, but inside a box that's placed above the hive cover, where the sun can hit it sometimes and mess things up. Here you have on the left side, a photograph taken with an infrared camera of the beehive we put the sensor grid into. You can see it there on the top of the hive with some heat from the bees coming up through it. Down in the bottom in the brood box, you can see the heat from the bees escaping out through the side of the box, and it's showing up on the infrared camera. Over on the right-hand side of the slide, you can see the data from the temperature sensor grid. These are average temperatures for a few days, about the time we put the grid on the hive. You can see that the temperatures are warmer in the center of the hive and cooler on the edges of the hive, especially in the corners. The color coding is an automatic function of Excel. The temperatures in the corners are about 50 degrees Fahrenheit or about 10 degrees Celsius. Temperatures in the middle in the 60s are about 15 degrees Celsius. Here you have a time series chart of the data from the temperature sensor grid for the first 10 days that it was in the hive. There's a number of features of interest here. One that stands out is the temperature from the external sensor, which shoots up in the morning when the sun hits the box that the electronics are in, and then goes back to being the cold outside temperature. The other thing that's very obvious is the periodicity of the chart here. Every day shows up quite nicely for this 10-day period. You can see that not only does the exterior temperature shoot up, but the temperatures inside the hive all shoot up in the morning as well. They go up quite quickly when the sun hits the hive and then gradually cool down over the course of the day. You can see that the coldest temperature inside the hive is about the same temperature as the exterior of the hive. You can also see that all these temperatures go up and down in unison, which means that every part of the interior of the hive goes up and down in unison. No part is consistently warm. In other words, there's no obvious place where the bees form a winter cluster, not from this diagram, although there are spots here clearly where temperatures are warmer. Some temperatures are warmer than others, meaning that some locations in the hive are consistently warmer than others. Finally, again, this grid is on top of the honey super, so not above the brood box. Okay, in the next slide here, we have jumped ahead to early March for a 2-week period. And you can see, again, the daily temperature rise and falls on the exterior temperature sensor. You can also see that some of the interior sensors follow that same pattern, but many of them don't. And in fact, if you divide this time series in the middle, you can see that the left side is different from the right side. And the very first day over on the left, you can see the temperatures. Some of them, while they're warmer than the outside temperatures, because the bees have warmed the entire interior of the hive, so all the sensors are warmer than the outside sensors. But in this case, some of the sensors, even though they're warmer than the outside temperature, still follow its basic movement, whereas some of the other ones are high and steady, although they're lower than the brood temperature, which is marked by that horizontal line. Then over the rest of the week for that period, the first week, you can see that temperatures come up until they're pretty close to brood temperature. In fact, you could say the warmest ones were just at brood temperature and holding steady. And then in the second week, you can see that a number of temperature sensors are recording temperatures well above brood, the minimum for brood temperature, and holding steady. So that you can say here in the first week of March, you can see that transition from no brood near the sensors to brood right under the sensors. And sure enough, when we popped the cover and took a look in the hive, we could see that there was brood right under the sensor grid. At that point, we did a couple of things. First, we took the average temperatures under the grid for that last week, and you can see those on the right. Temperatures are up well into brood temperature in the middle of the hive and nearly at brood temperature at the front end of the hive. And over on the left side, you can see there was brood right under the sensor grid. And at that point, we did two things. We moved the sensor grid from above the honey super to above the brood box so that we began measuring temperatures in the brood box. And also, at that point, we split the colony using the brood from the honey super and putting that into a new colony. Here is the following week. The data is averaged for the week following the week I just showed you, again, just from the front half of the hive. So the first two rows in this table are the sensor IDs. The next two rows in the table are the temperatures at the front of the hive, and you can see they're all above brood temperature, the minimum brood temperature. The next two rows show you the standard deviations for the temperatures in those locations. And you can see that the standard deviations are quite low, indicating, as I concluded in the bottom two rows, that there is brood under every sensor in the colony that we have data for, except for those two outside walls of the hive. So taking that as the first point on this chart in late March, and here we have the data for the amount of brood in the brood box from late March to early June. In other words, over the springtime period. As I said, we split the colony the week before starting this chart in hopes of preventing a swarm, but that didn't happen. We got a swarm right here on April 6th. And that may account for some of the loss of brood from the queen shutting down. And then you can see we went from 100% full of brood in the brood box down to only about 20% of the brood box having brood in it. Really a surprise for the early spring. The next thing that happened, again to our surprise, was two more swarms, one on the 20th of April and one on April 22nd. But eventually, they made a new queen, and the new queen began to lay, and she began filling the brood box with brood once again as spring turned into summer. To summarize the amount of brood and where it was located over this time, I made this chart. So this is looking down on the top of the hive. So we've got the 4 rows of sensors, the 9 sensors in each row. And this shows you the percentage of time there was brood under each sensor. You can see that in the center of the hive, those red spots there, the 5 red ones, had brood at least 85% of the entire monitoring period, while the locations marked with blue had brood less than 15% of the monitoring period. And between those two, the brood came and went as the bees raised brood or the brood matured and came out of the colony. So that's the pattern of brood overall. For this data, for the ability to gather this data, I should say, I'd like to thank my developers who were graduate students at the Catholic University of America. Anna Stum was the electrical engineer, and Brett Padula was the mechanical engineer, and their professor was Greg Behrman. I'd also like to thank my beekeeping partner, Gail Ifshin, without whom I could not have done this work. So to summarize, a sensor grid in the hive reveals several surprises. First of all, in the winter cluster, it showed its location and the temperature fluctuations, but it also showed that, contrary to the literature, there was no cluster edge. The second thing I showed you was the transition to brood rearing, which became quite clear. And the third thing I showed you was how the amount of brood varied over the springtime period, when you would have thought the colony would be full of brood, but instead it was only 20% full. A rather big surprise. I will take questions at the question period. Thank you very much for your interest, and I'll talk to you later.